We have already discussed the definitions and importance of solar angles in our previous videos of this series. Link of the video is in the description. Also, it's in the I button above. Please watch the previous videos in this series to know about the importance of measuring these solar angles. Before we begin, let me tell you that here we have discussed about two approaches or methods to measure the solar angles. So, we have divided this angle measurement video in two parts. Each part is for the one separate approach only. And this is the first part of the two-part video. Also, please note that the steps followed here will be required for inter-row pitch calculation. Solar altitude and azimuth angles are the inputs to derive the inter-row pitch. So, watch with attention, guys. You may take notes also, or download the resources from Google Drive. We have shared everything there for you only. So, let's begin. We'll calculate, or to be accurate, we'll get the values by two different methods. Both are web-based approach. Here are the links. You can get the links in the description below. Okay, so first, you need a computer or a laptop. Sorry, it's tough and time-taking to do this with your mobile device or smartphone. Second, an internet connection, which you have already, it seems. And offline tools like a PDF reader, PowerPoint, Google Slides or equivalent tool. And MS Excel or similar apps like Google Sheets will also work. And most important thing you need is the location coordinates of your solar PV site for which you are finding the solar altitude and azimuth angles. So, visit the Google Map website and search for the location. Once you pin the location, as you see here in the web address bar, you'll get the location coordinates like this. First number after the et and before comma is the latitude, and the second one after the comma is longitude. Copy this set of numbers and paste in a Word file or in a notepad and save it for future use. Now, let's discuss the first method. So, in this method, first, we need to visit the below web link. So, first open the link. This is a web application developed by University of Oregon by their Solar Radiation Monitoring Lab. In step 1, put the latitude and longitude of your desired location. For an example, we put the coordinates of a site in Andhra Pradesh, a state of India located in the southern part of the country. In the second step, select your location's time zone. In our case, we have selected the UTC plus 5 hours 30 minutes. In the third step, there are a lot of options. You can select any one among them to see various results. For inter-row pitch calculation, we considered the fifth option from top that says plot only this date. Then, below to this option, we kept it unchanged as we need to calculate the inter-row pitch based on the local solar time. From step 4 to 6, we have kept them as default and unchanged. In the seventh step, put the verification code and hit Create Chart button. On the next page, click the download option as it's marked in the screen. Now, open the file in any PDF reader. We used the Adobe PDF Reader. Now, in Adobe PDF Reader, go to the top menu portion and click Edit. Under this tab, there is a snapshot option. Select that one, and take the snap as we have shown here. It's now in your clipboard. Next, for Windows user, open PowerPoint, and for Mac or Linux user, recommend to use any presentation creator app for this. In PowerPoint, do Ctrl+V to paste. That's it. Drag and adjust to cover as much canvas area as you can. Now, zoom a little bit. Here, you can see the line represent the 21st of December and the intersection points from solar altitude or y-axis and solar azimuth or x-axis, which are distributed from sunrise to sunset at local solar time. Now, for an example to calculate the solar altitude and azimuth angle at 8 a.m. in the morning, simply, we draw lines from the 21st of December day curve to the y and x-axis. So, now you get the values of these angles. Obviously, on both of the axis scales, the exact numbers in 1 or 0.5 degree intervals are not mentioned. But you can approximate and round about the values. So, in our case, after the approximation, the solar elevation angle at 8 am is around 22 degrees and solar azimuth angle is 125 degrees eastward. Yes, approximately. Please watch the second part for the second method of solar angle measurement, which is more accurate and much simple. Please let us know how did you find this video helpful in the comments section. We read all of your comments. And please like and share the video as much as you can. Do subscribe to our channel Minutes to Energy for more interesting videos on solar PV system. Thanks for watching guys, see you in the next video.